Okay, so well, thank you everyone for coming to this workshop on AI datasets and model testing. So I'm going to start talking about the AI Act, a little summary, also the state of play, and then my colleagues Alex Taza and Alberto Alvarez, they will show you a demo on Citadel, a tool that tests AI. They will explain more about this. So I'm just gonna start with an EU AI update. So, as you know, the Commission proposed the first ever legal framework on AI. And the type of instrument chosen was a regulation because if you don't know, the regulation differently from a directive is directly applicable and uniformly applicable across all member states. That's why this type of instrument was chosen. So here we are talking about a horizontal regulation that applies across all sectors. So this means that applies to medical devices, to transport, to agriculture, so across sectors. And the aim of this regulation was to first provide legal certainty about AI. Then also the aim was to promote innovation in Europe because the EU was lagging a bit behind other countries like, for example, the US, but also the aim was to protect fundamental rights and EU values. So the EU AI Act applies to any provider that wants to put a system in the EU market. So here we see the extraterritorial effect of this regulation. So the AI Act is still under negotiation. So they are in the so-called trilogue negotiations. So you see that, okay, we have the proposal of the Commission, then we have the amendments proposed by the Parliament, and then the amendments proposed by the Council. So we have three texts. And now during the trilogue negotiations, what they are trying to do is to come up with a final text, which will be the final law. But when is this law gonna be ready? So here is the expected timeline of this. So the final law is expected to be published in the official journal of the European Union in the beginning of 2024. And 20 days later, it will enter into force. When a law enters into force, means that the law exists. But then after that, we have a transition period, which is a period for companies and everyone to get ready. And then the law will be applicable. So the transition period, we still don't know if it will be 2 years or 3 years because this is still under negotiation. So the Commission and the Parliament, they are proposing 2 years transition period, while the Council is proposing a 3-year transition period. So we expect the law to be applicable either 2026 or 2027. And from this date onwards, the regulation will produce rights and obligations. So what is AI? This is a critical point in the negotiations because we have the Commission proposing a definition on AI that refers to a list of computer science techniques. And beyond machine learning, they include also older knowledge-based approaches as well as statistical approaches. So what happened with this definition is that everyone considered that it was too broad because it could cover basically any traditional software that was not even AI. So what the Council did was to try to narrow down this definition to AI systems developed through machine learning and logic and knowledge-based approaches. But then the Parliament tried to, again, broaden a bit the definition and define AI without referring to any computer science technique, and included the notion of of predictions because they wanted to make sure that generative AI models like ChatGPT was covered under the scope. So now, yeah, they are debating between do we want a broad definition or a narrow definition. So this is a critical point in the negotiations. So I'm sure that you have seen this pyramid many times because what the original proposal of the Commission is proposing is a risk-based approach. So like in a pyramid, you have below those systems that are minimal or they have no risk at all. So these systems, they are not covered under the EU AI Act, so they don't need to comply with requirements, but the EU AI Act says, okay, codes of conduct are encouraged, and a clear example of this are these spam filters for Outlook. But then we have those systems that are limited risk, they, again, do not bring a risk to safety, health, or fundamental rights, but because of the nature of these systems, they need to comply with certain transparency obligations. So a clear example of this that is very trendy now in social media are deepfake systems. You know, these systems that impersonate celebrities. So in principle, they are not forbidden by the EU AI Act, but because of the nature, because it's very difficult to differentiate a deepfake video to see if it's real or not, they established the obligation to disclose that what you are seeing has been AI generated. Then we have high-risk AI systems. This is the main focus of the regulation. So these systems, because of this risk for your health, safety, and fundamental rights, before entering the EU market, they need to pass a conformity assessment procedure. And you have here several examples. One that has been very debated and still is being debated in the negotiations are real-time and post-remote biometric identification. But then you also have other examples, which is AI systems used in critical infrastructure, education, employment. So here what the Commission tried to do is, instead of regulating the technology itself, regulate the use of the technology. So the use in law enforcement, the use of AI in migration and border control. So here it's classified as high risk. And then on the top, we have an acceptable risk, which are those systems that are contradictory to EU values, and the Commission don't want these systems to be in the EU market. And here again, you have several examples. For example, AI that are used for subliminal manipulation, to exploit the vulnerabilities of certain type of persons. Real-time remote biometric identification systems in publicly accessible places by law enforcement, with several exceptions. So again, this is still under negotiation. This can change, and the final text probably we will see a different pyramid. Okay, so how do you know if your system is high risk or not? So your system will be high risk, so you have to check whether your AI system falls under, so if your AI system is used as a safety component of a product, or is a product itself that falls under sectorial legislation that you find. If you go to Annex 2 of the law, you find a list of sectorial legislation, and if your system is already covered by that list, and plus already under that sectorial legislation needs a third-party conformity assessment, then your system is high risk. So a clear example of this would be a medical device that is covered under the MDR that has an AI component. So here we have a high-risk system because we have the medical device that is covered under the sectorial law of medical device regulation, and also needs, if it needs a third-party conformity assessment. Then another way to classify if your system is high risk or not, if you have a standalone AI system, and it's covered by the uses listed in Annex 3, which are the ones that we just seen, the use of AI in employment, in border control, etc. So this is a more graphical way to see if your system is high risk or not. You ask if your system is covered by Annex 2. If the reply is yes, then you ask, is under that legislation a third-party conformity required? If the answer is yes, then it's high risk. Again, if your system belongs to the list of Annex 3, if the reply is yes, then it's high risk. So if your system has been classified as high risk, that means that you will need to comply with requirements that the AI Act lists in the regulation. So first, you will need to establish and implement a risk management process. Then you will also need to use high quality training, validation, and testing data that is representative, for example. Then you will need to establish documentation and also design logging features. This is for auditability purposes and traceability. Then you will also need to ensure appropriate level of transparency, and you will need to provide with instructions of use. Then you will also need to ensure human oversight, which could be either integrated in the system or be implemented by users. And finally, you will need to ensure that your system is robust, is accurate, and is cyber secure. So, as I mentioned before, if your system is high risk, it will need to pass a conformity assessment procedure. This conformity assessment procedure can be either carried out internally or by a third-party conformity assessment body. There are two situations where a third-party conformity assessment body is mandatory. And this would be in the case of those standalone AI systems that are used for real-time and post-remote biometric identification of people. We have seen this in Annex 3. So for those kind of systems, it's mandatory to go to a third-party conformity assessment body. And then you will also need a third party when your system, your high-risk system, is a safety component of a product that falls, again, under harmonization law that you find in Annex 2, and under that law already requires a notified body. Then you will also need a notified body. So the notified body will need to assess the quality management system and the technical documentation. And it can happen that if it's necessary in order to carry out the conformity assessment task, it's possible that the AI notified body can have access to training, validation, and testing datasets. Also, something important to note is that when the AI notified body is checking the technical documentation and the data that the AI provider has provided and sees that there is no evidence, no clear evidence of compliance with the AI requirements, then the notified body can carry out the test itself to make sure that the AI system is compliant with the requirements that we have just seen. And then this means that notified bodies can have access to the source code of the AI system if needed for, again, the compliance with the AI Act requirements. And here you can see the piece where this is mentioned in the AI Act. So standards are very important for the compliance with the AI Act requirements. So in the AI Act, we find a presumption of compliance with harmonized standards. So this means that if there are harmonized standards available and they cover AI Act requirements and you comply with these standards, it means it's presumed that you are compliant with the AI Act. So you see here some sources of standards, and something relevant to mention is that the Commission has already published a request to create these standards, and they are supposed to be out, supposed to be ready by the time the AI Act is applicable. Okay, so talking about standards, I go back to the beginning and explain a bit more about this Citadel tool. So BSI has partnered with Citadel AI, which is a Japanese-based company, which provides automated AI testing and monitoring tools, and that what it does is to measure if your system is compliant with technical standards. So now my colleagues will show a demo on this, how it works, and will explain you more about the details of this system. So, thanks.
Good morning, everyone. Okay, so as my colleague Ima said, we're going to be giving you a demo of the platform that we have been developing together with Citadel over the last year or so. So this product has been evolving over the last few months because, as you know, standards are still evolving. So we are trying to create this tool and update it constantly to keep up with the latest standards and the changes to the standards. I will show you some of the ISO standards that we will have to benchmark against. And this platform, this tool will be utilized eventually once the conformity assessments are enforced by the EU AI Act. But before we get there, I will just explain the context, otherwise it's going to be difficult to fully abstract the idea of why we're using the tool. So, hypothetical case where my colleague Alberto has developed a medical AI model for colon rectal cancer and health tissue screening, right? And he's making those claims, 98.89% accuracy, everything is 98.89 or 88. Within the technical documentation that he's required to provide according to the AI Act, because it's a high-risk system. He's providing documentation. It's a state-of-the-art efficient net model B0. He's also claiming the model is robust to some perturbations, namely blurring and brightness. And as an assessor, I would just try to benchmark his claims against the standards that currently are supported by the tool, so that you have a quick insight as to what the data set or the domain is. ADI, adipose, debris. We are really interested into TUM, which is the tumor itself, and STR, stroma. But the model classifies the images into 90 different classes. Okay, so now let me start with the presentation itself. Okay, so this is basically Citadel Lens, which is the product that we have been helping develop with Citadel AI. And in its main structure is very simple. You have projects, and within projects you have data sets, obviously models, and then the reports. I will create a new project, so let's call it WSI 23 demo. I'm not wearing my reading glasses, so if I type anything wrong, just shout out. Okay, so before I actually press submit, just to give you an idea of the capabilities of the tool, you select a project, you define the data type, in this case tabular or image. We are talking about image classifier, So definitely image types. You have Dicom, RGB, 2D, grayscale, and then the type of predictions, binary, object detection, multi-label classification, whatnot. If you, depending on the type of the project, if I were to select the tabular, then I would have maybe an anomaly detection enabled. Some of those features you see grayed out as still in development. Okay, so that's why I said that the product is in continuous development. Okay, so the project is now created, and that's where the interesting things start to happen. Let's create the data set. So Alberto, as part of his submission, has provided all the data sets, all the technical docs, some other stuff, literally review and whatnot, but I'll start uploading the training set. And this is the training validation set. Label name, true class, because we're talking about images. I'll just add the data set. If the internet speeds are the same as yesterday, it should take exactly 27 seconds. We'll see. Yeah. Someone is watching YouTube. Okay, that's done. I think it was a little bit over 27 seconds. Let's also upload the test set.
That should be faster.
That should be much faster. But demos are demos, so anything could happen, right? Even a full crash of the system. Okay, so both data sets have been updated. Let's have a quick look at the training set. So you can see there are about 6,500 images, 90 different classes, which correspond to those classes, ADI, TUM, STR that I explained before. And we can have a quick look at the data statistics as well, so the distribution of, given those are images, brightness, contrast, and sharpness. You can see also the distribution of the target labels. So ADI, stroma, tumor somewhere in here. Yeah. And you can see, it's not a proper balanced data set. Might not be relevant at all for this case because, as you know, VO world problems, you don't always find a balanced data set. So there is always a sensible explanation for that. But we'll be obviously making sure that if the data sets are not balanced, that there is a rational justification behind that. So one of the things that I will be doing is, in order to facilitate my analysis of data later on, I will just ask the tool to automatically create classes. I know there are 9 because we saw before. So just generating segments so that I can then later on do the analysis per segment, select the accuracy for tumor or the accuracy for stroma. Did I click?
I think so, yeah.
Maybe. I clicked. That's right. Yeah. I don't even bother anymore, and I'm so used to those things, demos. I'll just do a refresh. Oh, yeah. You see? See, no internet. Oh. I'm actually connected securely.
There you go. Let's try again.
I would just blame the organizers. Anyone from the organizers here? It's just to check the internet. No, I can't. You know, it will show my browsing history, so rather not. Okay, I guess if we don't solve that, what I'm gonna be doing is I'm connected to the VIP speaker, which is not so VIP, I would say. Let me disconnect and connect again. Can you ask the other speakers to stop their presentations, please? Just
Yeah, let's try again.
let's start again. Do you have a new one? Okay. The one, yeah? Yeah, they are doing their thing over there. Password, please? Just shout it out loud, right? No security issues whatsoever. No, it's fine. Okay. I don't think I can reach this actually. Let's go to I'm gonna go. Old AI Summit Internet Crash. Let's see if it works. No. All right. So I don't know. Maybe it's just because I'm too old and I've been through situations very similar to this in the past. I might have a video which is not ideal, but at least get us going.
Yeah.
Yeah. All right.
The personal hotspot is pretty fast if you want.
Wow. Yeah.
Romantic.
Let me see. Where are you here, Roman?
Watch it. Yes,
Which one?
this one. This one.
Okay.
And this is password pro.
Can you type in? As I said, no reading glasses. Just checking. You're not a certified hacker, right? You know, I don't know. Yeah.
Okay.
Okay.
Try it.
Perfect. Thank you so much. Oh, I'll leave this here. Just wanted to get super close to my laptop, okay? Thanks. No. Hey, thank you so much. Hey.
Save the day.
All right, so where I was, yes, data sets.
About to upload models now.
No, I was about to show the training data set, I believe, right? So we've seen this. We saw the data statistics, images, unbalanced. Just show you a little bit of the images here. And now we're going to create the segments. Yeah. You see, super fast when you have an internet. And okay, jokes aside, now the tool has automatically created the different classes based on the segments. You can see easily here 18%, 17. You get pretty much the same distribution as you got on the chart. Let's look at the testing data set as well. Do the same. Test set. Let's create segments based true class 9. Generate segments. Done, 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 done. Yeah. Okay. So test data set, 700 and odd images. Again, the same classes. We can have a quick inspection of the images that are there. In this case, let's just show what a tumor might look like. I'm not a medical expert, but they look awful to me. Let's see. Now we will definitely load up the model. And as part of the documentation, I know this is a PyTorch model. As you can see here, Citadel does offer the ability to load up a number of different models, from Keras, TensorFlow, PyTorch, ONNX, OpenVINO, Docker, and some others. As I said, as time goes by, we'll be adding more and more types of models to that list. This one is PyTorch. Upload the model is this one, and I need also to upload the pre-processing image file. So in Keras, this is not required, as you can add just the pre-processing layer as part of the model itself. PyTorch and others that do require a processing file to be uploaded. Everything has been provided by Alberto, so I'm not changing any of the characteristics of pre-processing, data ingestion, nothing.
Yeah, these are all, yeah.
One other thing I remember is that within the technical documentation, Alberto mentioned somehow and somewhere that the model doesn't really output probabilities.
Yep.
So I'm going to be using Citadel's features to actually say, please do output probabilities for my own testing. That's done. And now we have the data sets, test set, training set uploaded, the model uploaded, and that's where things really start to get interesting. Up to now, it was just loading input data, right? Now, as Ima said, there are a number of standards being developed, and they're going to be harmonized most likely under the EU AI Act. And some of those reports, or standards rather, are the ones you see on the screen. We will today focus on 4213, which is about classification metrics. And Alberto has made those absurd claims of nearly 99%. I just want to check whether he's telling the truth or not. So I'll create a report, and that report should automatically calculate all those standard metrics as defined by the standard. I have no idea, apart from his claims, and I haven't seen any real outputs from his model. All I'm getting is a little bit of technical documentation, some claims. I'm robust to blurring and whatnot. So I'm coming in totally partial to this thing. I selected the model, I selected test set, and I will select the 4213. So machine learning classification performance. Just added the report, and that was pretty quick. I think now it's going to take 41 seconds to process the report.
But that was with the old internet.
Oh yes, now someone, the gentleman suggested it was much faster.
There you go.
Oh, you see, well, great. I should have arranged for this fast internet before. So you see here, a number of different tabs. So this is the 4213 model report. It basically incorporates all the required metrics as defined per the standard. I just want to bring to your attention that if the standard says that you should be using matrix A, B, C, and D, it doesn't necessarily mean that you need to be using all of them. You need to justify your choices. And also, it doesn't mean that you cannot use other metrics. You might have different metrics that you want because that's the way you do your AI developing, as insofar as they are justifiable, obviously. If you say, I'm using metric X for a binary classification problem that is not a binary classification evaluation metric, that's wrong. But in this case, the report basically generates automatically the confusion matrix. Initial indications, just a quick glance over this confusion matrix shows that the model actually is pretty good. One mucus that is being classified as adipose, and some stroma being classified as mucus, I think. I'm reading the other way around, but now that's where things really get interesting. But at least at first glance, I can see that what Alberto is telling me is actually might hold true. Accuracy, we said 98.89, right? Wow, that's 98.89.
Yeah.
Great. Let's see, I remember, I think precision was for weighted average 98.89. Yeah, we still got that. So yeah, so far so good. Fantastic. Let me have a quick look at accuracy for those segments that I created automatically early on. I'll just select all of them, it's easier. And you can see that out of the bunch, most of them have a very, very good accuracy, some of them even 100%, and then stroma is the lowest accuracy. But still, everything that I'm seeing here is within the parameters and the claims that Alberto has made, which is good. Yes, sure.
So one of the ways to kind of cheat is you can actually have some of your samples in your, or something similar samples in your test set or your training set, right? We call it data leakage, where you've got the same images, say from the same patient that you might. Is there any way you have where you can actually detect that there's similarities between the images?
If you
Might indicate that there's some cheating going on?
Absolutely, there is, because we don't trust Alberto, and that was the first functionality we implemented.
I'm looking pretty bad here. I mean.
I'll show that functionality later on, if you don't mind, okay? So far, so good. But hey, Alberto also made those claims about being robust.
Yeah.
I remember that. I will just go here and create a 24029-1 report. If you want to get bored to death, go and read the -2 and the -3 that is coming out. Super nice reading. Again, same model, same test set, and I will select 24029, and I will create, Alberto said that was brightening and blurring, right? Yep. So brightening, I'll just say 01 to 02. Just a little bit of brightening. Yeah, you can see that the tool does indicate a little bit how that perturbation might impact the source image.
Yep.
And the other one is blurring. I will do a little bit of blurring. I know I'm not with my reading glasses, but that one seems too blurred to me. So let's make it less of a blur. Yeah, 1.3 sounds about okay. So looking at naked eye, they seem decent images, right? If it was actually X-ray image or the images we are using for our test data set, if they were blurred like that or brightened like that, a doctor might say, yeah, they look okay. So let's see if that actually works. So I will create 2 tests. One is for the brightening claims. I will say, okay, 5% decrease in accuracy after the data set is perturbed. I will accept that as a good robustness test. And I'll also create one for blurring. And blurring, let me choose, I will accept a decrease in precision weighted average that is lower than 3%. Press the create report. the report is created quite quickly, and now it's just processing. So now it's going to take a little bit of time, not too much, don't despair, probably 1 minute or two, where it's taking the original test data set that Alberto has provided and applying all those perturbations. So it's randomly picking up a sample of those images and applying the perturbations for brightness within those thresholds that I specified. There are a number, as you've seen, of perturbations that you can apply. I know just on the interest of time here, I'm selecting only 2, but there are more than a dozen of those perturbations you can apply. Okay, so the report now is done. Let me check. Brightening. Okay, it's a pass. So let me see here. We said we accept a decrease in accuracy of 5%. The original data set was 9889. The perturbed data set 9708. So yeah, pretty good. We can see the original confusion matrix. I can see the now perturbed confusion matrix. And I can make some correlations or assumptions here that, for instance, lymphocytes are not that robust to brightness. Most of the errors have happened here. Maybe as a developer, can take that information and try to optimize your model a little bit more. But for me, it's a pass. Let me also, when I'm exploring the perturbed data set, I can compare all the metrics side by side, original data set, perturbed data set. And one of the interesting things is also you can see the perturbed images, and it shows you the highest error. So you can see here, it's predicting us 99.7%, but it's still, completely wrong. Yeah? And you can see that why brightness might impact the accuracy of your model. Okay, but nevertheless, it's a pass. Let me check blurring. Well, blurring is a fail. Okay, so we accepted a 3% decrease, even if it was 6 or 7%, it would be a fail. And we can check the confusion matrix. Wow, an astounding number, 72% of the muscle tissue is being wrongly classified as stroma. That's super bad. Obviously, failed. I can go and do the same checks here, accuracy per class, accuracy per data set, perturbed and not, and then see what the perturbed images actually look like again. Okay, not bad. I'm not here to be the police. We will not. There is no standard that sets those thresholds. So those thresholds were arbitrary thresholds that I set up based on my medical experience. Like, I don't like tumors when they look ugly. Yeah. It's one of those things that there is no standard that whoever set is say, well, if you fail by 3%, that's a fail. It's just an indication of how your model is performing under certain conditions. Yeah. The standard will just say, by the way, please make sure that within your processes, there are methods and checks that ensure that the data set and the model are robust to variations in specific conditions that might occur within your particular context. If you are, for instance, one machine, one OCT scan from one given manufacturer, and you have just one, variations in brightness, very unlikely to happen. So even if I say I accept 5% and it's a fail, you will justify and say, well, sorry, but my machine will always produce that same brightness. And that's fine. So I don't want to put anyone off with the fails and passes in robustness, because they are just indicators of how the model performs under certain conditions. Now, one of the things I was doing whilst I was checking all these data sets is that Alberto also provided, just a massive zip file with tons of folders, even content that I shouldn't have seen. And amongst those, there was an undocumented data set. Just because I'm very professional, I'll load those up and see what happens. I got a clue, is new patients, but I don't know. It could be just a wrong name for the data set. But I will just run the data set against the reports. Let me check before if this data set is actually the same stuff that we are talking about, because it could be a different data set, different images. It could be, as far as I know, even CSV files. I just got this data set. All right, let me look at the data annotator. Yes, they look like the images I had. Let me just check. 9 classes. Yeah, so I'm pretty confident this data set of new patients that is not mentioned. Yeah.
How did you get the classes? Is it from the name?
The 9 classes? No, so there are certain requirements when you upload data sets to Citadel, pretty much in the same way as in Keras TensorFlow, for instance, use the data flow from directory, like the data loader, or in PyTorch, similar, right? You need to create a folder with, I'll go with the basic example, cats, all the cats images, dogs, and so on. The zip file we saw has that folder structure. That's how it automatically gets. For the cases where your model is using a different type of data loader, it could be a custom data loader, you will then ask you to provide a text file with all the classes names. So you can provide, so there are different ways of ingesting data. Yeah. Okay, just so for, I'll create the same segments here as we did in the past.
You did click this time.
Did I? Oh, maybe the generate segments is cursed. Well, the good news is I don't actually need to generate segments for this. I will just go back to the model. Yeah, no, I think we lost the connectivity. I think who did provide me with the phone? You. I think I run out of data here. I know. Sorry. Next time, get that 50 gig package.
Yeah.
I didn't.
Switch it back to this one.
I didn't. I always like to blame technology. You see? Fine. Let me try again. Okay. Thank you. Again. Wow. So, oh yes. Let's just create the segments. 9. Great. So, just to recap, I've uploaded this undocumented data set. Images appear to be very similar to the ones I had in the training and test sets. So I'll just run a new report again, 4213. I can click anywhere and check the results for that specific data set. So as you see here, you've got the model, the same model. I'm just going to change this to the undocumented data set. That's under the report. Should be pretty quick. It's processing. Okay, so what is doing that? Not done? No. I will actually go and show you the data distribution of that data set. I'm still connected. Okay. So as you can see, this is a data set of new patients, and the distribution of the classes appear to be very well balanced. I'm hoping now that the report is done.
There you go.
Yeah, just about. And let's check again those claims that Alberto had made. So let's go to the confusion. Wow. Confusion matrix looks a little bit different now. Yeah. I don't even know where to start looking here, but it looks awful. Alberto, give me proper data next time. But you see in here, 82.48. So that tells me that the model that has been provided and the data sets that have been provided within the technical documentation, they are actually accurate. But by means of using the tool very, very quickly and easily, upload a data set that was there. And it happens, you are all there developing code, developing the models, and you get data sets and then clinical trials, and then someone else throws new data stores at you. At some point, you kind of lose track of which data have you been using, unless you are a super mature organization with data governance and know the processes around data provenance and whatnot. It's very common for data to get, be archived or use data that you should not have been using, or do the tests on data that maybe were actually part of the training validation with data leakage. We'll explore the data leakage question further on. But for this, it's basically telling me that two things. Either the new patient data is from a different distribution, but probably not. Yeah? Alberto told me he has only one machine, only one CT scan, that's same manufacturer, so I would kind of exclude that. But it could, and again, I'm not drawing any conclusions, but as part of this benchmark assessment against the standards, I could potentially then say, maybe even if the sample images from training have never leaked onto the test samples, it might be that you are using similar patients. So if you have a population of, let's say, 100 patients, and you split your data set, and you are not concerned about patient IDs or patient distribution, you end up with 80 images of patient 1 in the training data set, and then 20 images of patient 1 on the test data set. And the model might make some conclusions and get super biased towards that. And the idea is of observing this behavior here is that maybe all Alberto did during his model creation and training and deployment was always use the same number of patients, the same sample population, whereas with the new N plus 20 new patients, the model gets confused. And that will be actually the real world scenario, right? You deploy your model and then you get people that you've never seen before. So Alberto's claims, in this case, I would dispute those, just because I can prove that they are not what Alberto said they are. And sometimes Alberto then can use the tool itself to identify how this came about. I want now, before I forget, is just to show you the report about
Dataset comparison, yeah.
Dataset comparison. Okay, so for the image demo you're running now, I can do that. I will select the datasets. I'm adding the report. And what it's doing, it's processing, back to your original question, if you have tabular data, for instance, the tool will automatically detect, if you run this report, whether or not samples from training have leaked onto the test set. You can also create custom rules and say, show me all the samples that have class XY percentage. So you show, and then you automatically try and match those columns with anything that has that, and you can compare. And the tool will automatically assume that anything that has got X, Y percentage anywhere is a duplicate row. And it's not going to make any decisions on whether it's or not. It's up to you then as a domain expert to understand your data set and see if there are duplicates actually or not. But for the, if you don't customize anything, just press the button and you have 5 features, A, B, C, D, E, and you get those same 5 features on the testing set, and the values are identical. In any number of columns, you can specify, if you find 2 features that are identical between test and training, show that up as being a duplicate, or just one, or all of the 5. So there is this very useful feature that you can use to compare. It's much more useful within the tabular data, because the nature of the data you can really compare, whereas within images, all you can see here is whether or not the distributions of the data sets are similar. So on this case, I'm training set versus test set. You can see there are no major disparities between brightness between those 2 data sets. There are no major disparities in terms of contrast or sharpness. You get also the distribution of the classes. Yeah, let me expand this. Yeah, pretty okay, right? It's, tiny difference, but it's normal. I'm not seeing, the training set with 95% of a tumor and then the test set with 1% of tumor. I'm seeing things that are pretty normal here. So that's good. I'm now gonna check the one that is this test set versus the undocumented data set. And you can see here that there are not massive differences, but there are already some differences in terms of distribution of brightness and sharpness. And clearly, there is a massive difference in terms of the balance of those classes. So for images, this is what the tool is doing at the moment. There are discussions about whether or not we'll create more sophisticated filters for images, where it tries to detect, number of pixels and colors, and even most likely in the future to have object detection within the report itself. So 2 images, a dog here, a dog there, is the same dog, has just been augmented. The tool will try to say, well, this is the same dog. But this is for future development. Right now, the data leakage testing, training, the functionality that really works well is for tabular data. For the images, as you can see, is only distribution of the contrast, sharpness, and brightness. Okay. And that concludes the presentation. I do really apologize for the technical issues we had. I do really thank you so much for the Wi-Fi, and thank you so much for attending this session. If you have any questions, please just
Yeah, I have a question. So, is this testing, the recording of this stuff, will it be done by a data scientist from the European Union? Will it have to be done by some other company to verify my model, or will this work?
Okay, so as Ima put at the very beginning of the presentation, so we are BSI, we are working towards getting the notified body accreditation for AI. And once the UA Act comes into force, organizations like, hypothetical case, Alberto develops this model, is high risk, is medical. Yeah? Alberto then needs to submit the training sets, test sets, everything to BSI. And as part of our, once the UA Act is enforceable, and once you get our notified body accreditation for AI, then this tool will be one of the ways that this accreditation or the conformity assessment will take place. So will be our internal AI technical specialists that will be using the tool to validate, pretty much like I'm doing right now. Obviously, there will be additional features added on top of this as far as the tool is concerned. But don't forget, this is just a part of the overall requirements for conformity. There are things about risk management, processes, and whatnot, which need to be manually audited and verified. Any other question? In terms of, so if you are asking about the risk levels of the tool with regards to the EU AI Act, none, in the sense of we are not deploying the tool anywhere. We are not using the, well, we are not deploying the model will provide us anywhere. We are simply using the tool as a way of validating your claims. So all you're doing here is, you develop your model, provide the data set, we assess that those benchmarks and those claims are correct, yes or no, but the model itself will not be used by BSI in real world scenarios. So that's you as a customer who say, okay, now I'm certified, I can actually place my product onto the market.
Do you need maybe also some data problem documentation? Like how can the submitter prove that this is actually the data sets that have been used for training and testing?
Well, we certainly will request to oversee all the technical documentation. And obviously, different customers have different maturity levels. And as part of, forget about AI just for a moment. Just think about any certification process, any audit for quality management systems, or I don't know if you are in the software industry, back in the days, CMMI, or COVID controls for IT, right? So those assessments require the technology part and also require the processes part. So we will ask for documentation and see evidence. If you claim that, oh, my data set is from the real world, full stop, on your technical documentation, I will say, doesn't sound okay, right? Because tell me, do you have a tool internally that shows or confirms the provenance of that data, where that data has been acquired from? Has that data been acquired legally? Because you could acquire data from different sources. So there is always this extra layer of validation. It's about processes and maturity. Okay.
The main reason that the trains and tests are included here is only to compare the distribution of these data sets. I mean, you are sure that the model has been trained on the training set before, yes?
So the only reason I'm actually uploading the training data set, if that's the question, is just to show the comparison between the distributions. And if this was, as I said before, a tabular data, then I could also generate a report that says, please tell me whether or not there are any actual duplicates in here. For the image, is more about checking that the distributions are similar and checking that then on the dataset comparison report that I can know that the distributions of the image attributes are similar as well.
In case that you have a very huge data set, it is possible to only load parts of the data from training sets.
Well, how we're going to ingest the data is really down to how the end customer provides us the data. So if you provide me with 1,000 tiny zip files, I will ingest 1,000 zip files. But then if I need to treat each and every one as individual files, let's say validation phase 1, validation phase 2, that needs to be within your technical documentation. If I just get a bunch of files, in this case, I got 3 files and I had time, so I investigated that extra one. If you just provide me 1,000,000 files, I will ask you what those files actually mean. You're going to be telling me how to upload. So the conformity assessment, once the EU Act is in force, is a two-way process. We are not police. We are just here to make sure that whatever claims you're making are for real, and that's all. Okay, so I'm being told that I need to shut up. So again, I appreciate your time. Thank you so much.